Hello, this is going to be a demonstration of brain perfusion 4D on Vitria using version 7. The very first step is to select your patient, come down to the Applications tab, find your brain perfusion 4D application, and select Open. Vitria is going to go ahead and process the data, and it's going to go ahead and automatically apply motion correction. This process can sometimes take a couple minutes, so we will wait and let that finish processing. When Vitria is almost done processing, your time density graph will populate on the left-hand side, and our 3D circle of Willis will also be available. I'm going to go ahead and minimize our perfusion analysis tab on the upper left-hand corner so we can evaluate and see if we agree with our arterial input function and our venous function, or venous output function. If you go ahead and single left click on your red line, Vitria will take you to the slice that it determined was the correct arterial input function. Directly below the time density graph, you have a slide bar that you can move forward and back through time. If you would like to change the location, if you come up to your toolbar, you have an ellipse ROI tool. I'm going to draw an ROI around the area that I would like Vitria to search. I'm then going to come to the left-hand side and click the artery button. That will search my specific ROI for the new placement of the arterial input function. I can also click on the blue graph to find out where Vitria determined was the venous output function. Since it's a venous vessel, we're going to slide the bar just to make sure that we are most definitely in a vein. If we agree with this, we can go ahead and hit compute to recompute our perfusion maps. While that's processing, if we would like to take a snapshot of our time density graph, we can select the little arrow directly above the graph and select Take Snapshot. Once it's done computing our new arterial input function and venous output function, we can come up to the layout section at the very top. We want to select the 6-up 3D layout. This is going to show us our raw data. It'll also give us our perfusion maps. Down at the bottom of each viewport will tell you what type of map is in that viewport. The top middle, we have our relative cerebral blood volume. Top right, our time to peak. Bottom left, our cerebral blood flow. Bottom middle, our mean transit time. And our bottom right will be our Tmax map. These are standard colors. If you left click on the color itself, you will have a few different options. You have a spectrum, tricolor, and grayscale available. If I would like to manually measure an ROI, I will minimize our perfusion analysis tools, and I will come down to the bottom here where we have the View Options section. I'm going to select the brain midline. To get an accurate measurement that mirrors itself, you need to make sure your brain midline is accurately down the brain midline. It will put a purple line on our maps now. If it's off a little bit or you need to adjust it, you can grab a part of that line and adjust accordingly. Once you have that in the appropriate spot, we can go ahead and select the auto mirror function. We're going to come back up to our ROI ellipse tool, and I'm going to put an ROI kind of right here in this part of the brain. That will give me a mirror on the opposite side. It'll also give the quantified data in regards to that specific map. That is a manual ROI. If you would like, there are templates that are already available. If you come down to the ROI templates section, you can select the drop down directly next to it. You have a few options. The first is the orbital, second is conical, third is conical with deep gray nuclei, and the last is vascular territories. I'm just going to put on the conical with deep gray nuclei. And if you notice, there are predetermined ROIs already put in place. If you would like to save a batch of this to be able to send to PACS, you can right click on any viewport and do a batch collage. That'll go through all 6 data sets and allow us to send those as a DICOM data set. To turn those off, you simply come back to the ROI templates and uncheck the box. That will take off the templates that we had put on. Next I want to talk about is a summary map option. Directly below the ROI templates, you have an option for a summary map. I'm going to minimize our graph so we can see the different options. We have a show button that we need to select. Vitria is going to go through and tint our image. Normal tissue is going to be highlighted green. Your ventricles will be highlighted purple. Any other type of abnormalities will show up red or yellow. The best way to view this is to go back to our standard 4-up 3D layout at the upper left-hand corner. In the 3D viewport, it'll give us a mismatch ratio and more quantified data for evaluation. You can scroll through and see what Vitria has come up with. This can also be created as a batch by doing a right click and doing a batch orthogonal view. If you just need a picture, you can come to your 3D image and select the camera in the upper right-hand viewport, and that will save that image. To disable that, we're just going to X out, and that will turn off our summary map. Something else that can be beneficial with doing the brain perfusion 4D is it gives you a circle of Willis image. A few options for the circle of Willis is you can create a batch 4D cine. If you right click, you have the option to a batch 4D cine. That will go through the entire data set and create us a DICOM segment that we can send to PACS. If you would like a different type of view, You can switch this. I'm going to change this to inverted MIP. And I'm going to create another batch 4D Cine. Now that I'm done with my investigation, I need to send my imaging to PACS. I'm going to X out of Brain Perfusion 4D. I'm going to come to my results section. I'm going to select all the images that I have created. I'm going to hold right click and select export. You will have a predetermined destination already selected, and you will select export. And that is a demonstration of Brain Perfusion 4D on Vitria version 7.